This is Holly Martinez and Julia Lindman, and this is our final inquiry project. We decided to research Mount Cotopaxi. Our question is, how did the natural resources of Mount Cotopaxi play a significant role in the socioeconomics of the surrounding region? And our hypothesis is, the surrounding towns and villages heavily rely on Mount Cotopaxi for freshwater meltdown. Should the active volcano erupt, the combination of lahar damage and flooding from the meltwater would destroy the cities of Cotopaxi.
Cotopaxi is located on the eastern cordillera of the Ecuadorian Andes and is one of the highest active volcanoes in the world and the second highest summit in the country, with a height of 5,897 meters. The volcano was built above the scar left by a major debris avalanche estimated at over 5,000 years ago and is part of the chain of volcanoes around the Pacific Plate known as the Ring of Fire.
Cotopaxi is a unique stratovolcano, being that it has one of the few equatorial glaciers in the world. This means that when mountains of sufficient height near the equator are cold enough, the snowpack at the top of the mountain doesn't melt away, and such accumulation over time creates glaciers. Cotopaxi's most recent activity has been in the form of steam emissions, melting snow, and small earthquakes in the late 70s, but Cotopaxi has a history of volcanic eruptions.
There have been more than 50 full-scale eruptions of Cotopaxi since 1738, and the numerous valleys formed by lahars surround the area in huge carved pathways seen clearly from the sky. Some of these lahars, which are a mixture of rock fragments flowing down the slopes of a volcano or river varying in size, speed, and composition, often eroding everything in its path, traveled more than 100 kilometers and reached the Pacific to the west and the Amazon basin to the east.
Cotopaxi's glacier has much economic, social, and environmental importance, as its meltwater provides fresh water to the nearby cities of Quinto and Licunga for human, industrial, and electrical consumption. However, due to various environmental factors, including global climate change, the glacier is retreating faster than ever.
In the last 25 years, it has seen its most rapid disintegration yet, with the ice mass decreasing 30% between 1956 and 1976 and another 38.5% between 1976 and 2006. This threat to the vital water source going to Quito and Latacunga is a significant aspect of this glacial-volcanic risk. The deep lahars going along the volcano pose a huge danger to these surrounding settlements as well, severely damaging roads beyond repair and hindering basic means of transportation, interstate commerce, and future prospects for infrastructure.
In the event of a major eruption, the meltwater coming from the distressed glacier would surely flood all of the surrounding cities, irreversibly destroying the already fragile and agricultural-heavy economy.
In terms of future research, Cotopaxi is one of the best documented ice caps in Ecuador, and in the past, scientists have been able to do extensive fieldwork on the volcano, including precise measurements, volume changes in the glacier's surface, and digital photogrammetry on thousands of aerial photographs.
These methods have allowed scientists and geologists to precisely track glacier changes since 1956 and create accurate hypotheses for melt patterns. Future fieldwork would just be an extension of this. As a geologist, hiking Cotopaxi and measuring the uneven masses in the glacial ice would be very interesting, especially when hypothesizing the fate of Cotopaxi's glacier in the next 30 years or so.